Hello, this is Jeff Stachler, the Auglaize County Extension Educator. Today I want to talk to you about nitrogen, a very slippery and elusive element, making it difficult to manage, but is extremely important to proper plant growth. There are several different sources of nitrogen that we can get into the soil. The largest or greatest amount is through industrial fixation, which is taking nitrogen gas and turning it into a nitrogen-based fertilizer. Another source is biological fixation, where legumes interact with bacteria to take the gas out of the air and put it into usable forms. We have livestock feces and crop residue that get incorporated into the soil and eventually into the organic matter. We can have atmospheric deposition, where ammonia gas in the air is taken out and put into the soil. And lastly, when lightning strikes, the electrical charges create a nitrate form of nitrogen that falls to the soil in the rain. There are two forms of nitrogen that plants require or take up, and one is NH4, ammonium, and the other is nitrate. So both of these can be taken up into the plant. We have nitrogen in large quantities in the soil. That's where the majority of the nitrogen is held, is in the organic matter. And when that nitrogen comes out of the organic matter through microbial processes, it comes out as ammonium. And when this happens, this is called mineralization. Again, mineralization is an addition of ammonium to the soil solution from the organic matter. This ammonium then goes through a process of microbial activity and is called nitrification when it goes into the nitrate form. So ammonium goes to nitrate through bacteria, and this is called nitrification. That nitrate then is very mobile. It's negatively charged, and so it doesn't attach to soil particles and is leached through the ground and getting into groundwater or into tile lines. Additional bacteria, when under anaerobic conditions or saturated soils, can go through a process called denitrification, where the nitrate is turned into a gas, and that is a loss to the system. Another temporary loss, or long-term for that matter, is when nitrate or ammonium goes back into organic matter. This is called immobilization. Again, microorganisms in the soil convert either nitrate or ammonium back into organic compounds and is not available for plants. This nitrogen that goes into crops, the grain that is removed is a loss to the system because we take that grain away from the field, and that's a loss to the system. And so that's the nitrogen cycle. So let's take a look at an example of the growing season with the nitrogen cycle. So if we look at additions, obviously in a corn production system, we're going to add nitrogen because the corn needs a lot of nitrogen. And on average, 160 pounds of nitrogen per acre is applied in Ohio. And then if we add to that the mineralization, again, the movement of nitrogen out of the organic matter into a usable form, most soils in Ohio average between 50 and 70 pounds of nitrogen released during the growing season. If we take the average of 60 and add to 160, we get a 220 pounds of nitrogen per acre gain to the nitrogen system. If we look at ways that the nitrogen is removed from the system. We look at the crop removal is the biggest portion of that, and looking at just the grain because that's what's moving away from the field. 170 bushel per acre yield contains 102 pounds of nitrogen per acre, because there's 0.61 pounds of nitrogen for every bushel of corn. We have to consider the leaching because some amount of nitrogen is in that nitrate form. On average in Ohio, that's 25 to 30 pounds per acre. That is lost. And then denitrification, again, when we have saturated soils, the nitrate is moving into a gas form. On average, that's about 40 pounds of nitrogen per acre. So if we take 40 and 30 and 102, we come up to about 170 pounds of nitrogen of loss during the growing season. That means we have ended up with a total of 50 pounds of nitrogen gained to the system. That is going to be in different forms at the end of the growing season. And depending upon whether it's in a nitrate form, may not be available for the next growing season. So that concludes the presentation about nitrogen cycle.